I'm sure you know Einstein's famous formula E equals mc squared. But did you know it's incomplete? Teachers usually don't show you the full expression right away. They ease you into it after half the students drop the class and decide to go into marketing. But the incomplete formula is only half the story. So I'm going to show you the complete version now. T-shirts and Hollywood movies usually leave out the gamma factor, but it's critical to understanding relativistic energy. So let's derive the formula in a way that's easy to understand and then cover a subtle but critical mistake in the way the gamma factor has been derived historically. Imagine someone firing a shotgun at a clay target that's flying horizontally at speed v. To hit the target, you have to lead it, aim to the right. The shotgun pellets travel along a diagonal path, much slower than light, but for now, let's just label pellet speed as speed c. That creates a right triangle. Horizontal side, the target speed v. Diagonal side, the pellet speed c. The depth side, which is the virtual speed from the shotgun to where the target was first launched. In other words, it's a projection of the diagonal pellet speed onto a line that connects the shotgun to the starting location of the target. Let's call this the projection speed. Nothing to do with physics yet, just geometry. We can compute the projection speed with a Pythagorean theorem for a right triangle, which gives us the square root of c squared, the pellet diagonal speed squared, minus v squared, the target speed squared. Nothing tricky so far. So now let's see how this relates to relativistic energy and momentum. We're allowed to multiply all three sides of any triangle by a constant value, so if we multiply all three sides of the triangle by c divided by the square root of c squared minus v squared, which happens to be the Lorentz gamma factor when c represents light speed, the projection speed from source to target at time 0 becomes c. The left to right speed of the target becomes gamma sub L times v, and the diagonal speed of the pellets becomes gamma sub L times c. This is just a mathematical construction. We just did something similar to converting euros to dollars while preserving the angles of the triangle. We simply brought the side lengths into physics currency. Okay, let's play around some more. Let's multiply all three sides by another constant, m sub 0, which we'll later call the rest mass of the target, and also by speed c. Again, we assume that m sub 0 and c are constants, so we're allowed to multiply all three sides of our triangle by them. It's like going from dollars to yen now. Every side of the triangle has the same intrinsic value, just expressed in a different currency. Yet now we have a triangle of energies instead of a triangle of speeds. Let's use the Pythagorean theorem to now compute the diagonal of this new triangle. The square root of the squares of the two smaller sides of the right triangle is equal to the diagonal of the right triangle. Think of our projected axis as our savings account and the horizontal axis as our checking account. Then the diagonal is our net worth after a very inefficient Pythagorean government takes away a large chunk of taxes. Do you know what we just derived? If c represents light speed, this formula is the famous energy-momentum relation. That's right, if c is light speed and v is the speed of an atom or subatomic particle, our formula describes the relativistic relationship between energy and momentum of the atom or particle that we are calling our target. The right side of our formula is Einstein's total relativistic energy of the atom or particle. The left side of our formula is the Pythagorean sum of rest energy of the particle squared plus relativistic momentum of the particle squared times light speed squared. We just derived this famous formula from triangles and clay targets. We didn't need spacetime or stress tensors or length contraction or time dilation or form momentum to derive the fundamental relationship between rest energy, relativistic momentum, and relativistic energy. We haven't discussed its meaning yet. That's next. But I want you to see that it's not so complicated. College physics textbooks will take it about this far, but there's some fascinating hidden relationships in the geometry that are rarely discussed, and I want to show those to you. These relationships explain the meaning of the gamma factor without invoking time dilation or proper velocity or form momentum or other mechanisms that I believe reveal fundamental misunderstandings of the real relationships in the energy momentum formula. In the next few episodes, we're going to ask questions that textbooks never address. Why does rest energy exist? In other words, why does something at rest have something called rest energy? What is the meaning of relativistic momentum? We have an intuitive understanding of momentum, but why does momentum increase hyperbolically by the Lorentz gamma factor with increasing speed? And why does total energy skyrocket as our particle approaches light speed? Spoiler alert, it has to do with crazy shapes called ellipsoids. You know, things that look like eggs or watermelons or footballs. Speeds that are not perfectly isotropic cause spheres to turn into ellipsoids, and ellipsoids hide the real energy relationships. In the next episode, I'm going to cover some of the history that helped physicists get to the wrong answer for the hyperbolic relationship between speed and energy, and then provide a more satisfying answer without invoking fantasy assumptions like crazy clocks that don't agree on time readings or matter that contracts based on who's looking at it. Okay, that's it for this introduction to energy. If you have any questions, please write them in the comments section. I'm Joe Sorge, and thanks for watching.